Based on the description provided, it is difficult to conclusively determine the type of fire alarm system installed in 1975. However, considering the presence of a rectangular junction box with multiple conduits and the lack of detailed documentation, it is likely to be a conventional fire alarm system. Conventional systems typically use 2 wires per circuit, but the presence of additional wires in this case may indicate the use of shutdown circuits or relays. It is possible to install an addressable class or fire alarm distribution circuit with shutdown circuits emanating from the fire panel using only a 2-wire system. This is known as a class addressable system. Unlike conventional systems, which use 2 wires for each zone, addressable systems use a single twisted pair of wires to communicate with individual devices. The shutdown circuits can be programmed within the fire panel software, eliminating the need for external relays or shutdown devices. Fault isolation monitors typically do not require additional cabling back to the fire panel. They are designed to connect to the fire alarm system's wiring and monitor for faults or open circuits. When a fault is detected, the FIM will send a signal to the fire panel, which will alert the operator. To accurately describe the scope of work for the upgrade, you could include the following information. The current system is believed to be a conventional fire alarm system. The system has multiple conduits entering a rectangular junction box, including power, backup power, and signaling. There are 15 shutdown initiating device boxes near the fire panel. The fire panel has 4 wires per circuit, indicating the possible use of shutdown circuits or relays. You intend to install an addressable class A fire alarm distribution circuit with shutdown circuits emanating from the fire panel. Fault isolation monitors will be installed to detect faults in the wiring. Let's delve into the specifics of fire alarm systems, focusing on the distinctions between conventional and addressable systems, Class A and Class B wiring configurations, and the role of fault isolation monitors. Understanding these elements is crucial for planning effective upgrades and ensuring the safety of a facility. Let's start with conventional fire alarm systems. These systems are characterized by their zone-based approach. Each zone encompasses a specific area within the building, and all initiating devices, such as smoke detectors and manual pull stations within that zone, are wired to a single circuit. When a device is activated, the fire alarm control panel identifies the zone where the alarm originated, but not the specific device. Conventional systems are relatively simple to install and maintain, making them a cost-effective solution for smaller buildings. However, their lack of precise device identification can delay response times and complicate troubleshooting. Moving on to addressable fire alarm systems, these systems offer a significant advantage in terms of pinpointing the exact location of an alarm. Each initiating device and notification appliance is assigned a unique address, allowing the fire alarm control panel to identify the specific device that triggered the alarm. This level of granularity enables faster and more targeted responses, reducing the impact of false alarms and improving overall safety. Addressable systems also offer advanced features such as remote testing and diagnostics, simplifying maintenance and reducing downtime. Now let's discuss Class A and Class B wiring configurations. These classifications refer to the integrity and reliability of the signaling line circuit, also known as the SLC. Class A wiring provides a high level of reliability in Class B wiring. In a Class A circuit, the wiring extends from the fire alarm control panel to the last device on the circuit and then returns to the panel via separate paths. This creates a loop, ensuring that the circuit remains operational even if a single break or short occurs. The fire alarm control panel can detect the fault and continue to communicate with the remaining devices on the circuit. In contrast, Class B wiring is a simpler configuration where the wiring extends from the fire alarm control panel to the last device on the circuit without returning. If a break or short occurs in the wiring, all devices beyond the fault will be rendered inoperable. Class B wiring is less expensive to install than Class A wiring, but it offers a lower level of reliability. Lastly, we will talk about fault isolation monitors. Fault isolation monitors, or FIMs, are devices that are used to isolate sections of the signaling line circuit in addressable fire alarm systems. These monitors are strategically placed throughout the building to limit the impact of a short circuit or open circuit on the SLC. When a fault is detected, the FIM automatically isolate the affected section of the circuit, preventing the fault from disrupting communication with other devices on the SLC. This ensures that the fire alarm system remains operational even in the event of a wiring problem. When planning an upgrade to a fire alarm system, it's important to consider several factors including the size and complexity of the building, the occupancy type, and the specific needs of the occupants. A thorough assessment of the existing system should be conducted to identify any deficiencies and determine the best course of action. If the existing system is a conventional system, it may be advantageous to upgrade to an addressable system to improve response times and simplify maintenance. The choice between Class A and Class B wiring will depend on the desired level of reliability and the budget constraints. Class A wiring is generally recommended for critical applications where system uptime is paramount. Fault isolation monitors should be incorporated into the design to minimize the impact of wiring faults. In addition to the technical aspects of the upgrade, it's also important to consider the regulatory requirements. Fire alarm systems are subject to various codes and standards, such as the National Fire Protection Association NFPA 72, the National Electric Code NFPA 70, and local building codes. It's essential to ensure that the upgraded system complies with all applicable requirements. Shutdown circuits are specialized circuits within a fire alarm system designed to automatically shut down certain equipment or systems in the event of a fire. These circuits are typically used to control HVAC systems, elevators, and other critical equipment that could potentially exacerbate a fire or hinder evacuation efforts. The primary purpose of shutdown circuits is to improve safety and prevent further damage to the building and its occupants. When a fire alarm is activated, the shutdown circuits trigger the designated equipment to shut down, reducing the spread of smoke and fire and facilitating a safe and orderly evacuation. Integrating shutdown circuits into a fire alarm system requires careful planning and coordination with other building systems. The specific equipment to be shut down and the sequence of operations must be determined in accordance with applicable codes and standards. The shutdown circuits must also be designed to ensure that they are reliable and fail-safe. There are two main types of shutdown circuits, normally open and normally closed. Normally open circuits require a signal from the fire alarm control panel to activate the shutdown, while normally closed circuits require a signal to deactivate the shutdown. The choice between these two types depends on the specific application and the desired level of safety. The location of shutdown circuits is crucial for their effectiveness. The shutdown circuits should be located in close proximity to the equipment they are intended to control. This minimizes the wiring distance and reduces the risk of signal degradation. The shutdown circuits should also be protected from physical damage and environmental hazards. The wiring for shutdown circuits must be installed in accordance with the National Electrical Code and other applicable codes and standards. The wiring must be properly sized and insulated to ensure that it can carry the required current and withstand the expected environmental conditions. The wiring must also be protected from mechanical damage and corrosion. Regular testing and maintenance of shutdown circuits are essential to ensure that they are functioning properly. The testing should include verifying that the circuits are activating the designated equipment in the correct sequence and that there are no faults in the wiring. The maintenance should include inspecting the wiring for damage and corrosion and replacing any defective components. When describing the scope of work for a fire alarm system upgrade to contractors, it's important to provide clear and concise information about the existing system, the desired upgrades, and any specific requirements. This will help the contractors to understand the project and provide accurate bids. Firstly, describe the existing system. Include the type of system, the number of zones or addressable devices, the type of wiring, and the location of the fire alarm control panel and other system components. Provide any available documentation, such as as-built drawings and wiring diagrams. Secondly, specify the desired upgrades. Clearly state the type of system you want to install, the level of reliability required, and any specific features or functionalities you want to include. If you are upgrading from a conventional system to an addressable system, be sure to specify the type of addressable devices you want to use. Thirdly, outline any specific requirements. Include any code requirements, insurance requirements, or other specific needs that must be met. If you have any preferences for specific brands or manufacturers, be sure to state them clearly. In addition to the written description, it's also helpful to provide the contractors with a site visit so they can inspect the existing system and ask any questions they may have. This will help to ensure that they fully understand the scope of the project and can provide accurate bids. Here's an expanded overview of fire alarm system components and considerations for upgrades. Firstly, initiating devices are components that detect the presence of a fire and initiate an alarm signal. Common types of initiating devices include smoke detectors, heat detectors, manual pull stations, and flame detectors. Secondly, notification appliances are components that alert occupants of a fire. Common types of notification appliances include horns, strobes, speakers, and voice evacuation systems. Thirdly, the Fire Alarm Control Panel, or FACP, is the central control unit of the fire alarm system. It receives signals from the initiating devices, activates the notification appliances, and monitors the system for faults. Fourthly, power supplies provide the electrical power to operate the fire alarm system. Fire alarm systems typically have both primary and secondary power supplies to ensure that the system remains operational even during a power outage. Fifthly, wiring connects all of the components of the fire alarm system. The type of wiring used depends on the type of system and the specific requirements of the installation. Sixthly, communication systems allow the fire alarm system to communicate with the fire department or a central monitoring station. This allows for rapid response in the event of a fire. There are different types of fire alarm systems that include conventional systems, addressable systems, wireless systems, and hybrid systems. Conventional systems are the simplest type of fire alarm system. They use zones to identify the general location of a fire. Addressable systems are more sophisticated than conventional systems. They use individual addresses to identify the specific location of a fire. Wireless systems use radio waves to communicate between the components of the fire alarm system. This eliminates the need for wiring, making them easier to install in existing buildings. Hybrid systems combine the features of conventional and addressable systems. When planning a fire alarm system upgrade, it's important to consider several factors including the size and layout of the building, the occupancy type, the specific hazards present, the local codes and standards, and the budget. The size and layout of the building will affect the number and location of initiating devices and notification appliances required. The occupancy type will affect the type of fire alarm system required. For example, a hospital will have different requirements than an office building. The specific hazards present, such as flammable materials or hazardous processes, will affect the type of initiating devices and suppression systems required. The local codes and standards will dictate the minimum requirements for the fire alarm system. The budget will affect the type of system and the features that can be included. Before beginning a fire alarm system upgrade, it's important to conduct a thorough survey of the existing system. This survey should include identifying the type of system, documenting the location of all components, testing all components to ensure they are functioning properly, and identifying any deficiencies or areas of concern. Based on the survey, a detailed design for the upgraded system can be developed. This design should include selecting the appropriate type of system, determining the number and location of initiating devices and notification appliances, specifying the type of wiring and communication systems to be used, and ensuring compliance with all applicable codes and standards. The installation of the upgraded fire alarm system should be performed by qualified and experienced technicians. The installation should be done in accordance with the manufacturer's instructions and all applicable codes and standards. After the installation is complete, the system should be thoroughly tested to ensure that it is functioning properly. This testing should include verifying that all initiating devices and notification appliances are working, testing the communication systems, and verifying that the system is compliant with all applicable codes and standards. Once the upgraded fire alarm system is installed and tested, it's important to establish a regular maintenance program. This program should include periodic inspections, testing, and maintenance of all components of the system. Regular maintenance will help to ensure that the system remains in good working order and will provide reliable protection in the event of a fire. Some of the benefits of upgrading a fire alarm system includes improved safety, reduced risk of property damage, compliance with codes and standards, and reduced insurance costs. An upgraded fire alarm system can provide early warning of a fire, allowing occupants to evacuate safely and quickly. This can significantly reduce the risk of injury or death. A fire alarm system can help to minimize the damage caused by a fire by alerting the fire department quickly and initiating suppression systems. Upgrading a fire alarm system can help to ensure compliance with all applicable codes and standards. This can avoid costly fines and penalties. Many insurance companies offer discounts for buildings that have upgraded fire alarm systems. In summary, upgrading a fire alarm system is a significant investment that can provide numerous benefits. By carefully planning and executing the upgrade, it's possible to improve safety, reduce risk, and comply with all applicable requirements. The selection of the fire alarm system wiring plays a crucial role in its proper functioning and overall reliability. The wiring serves as the communication pathway between the various components, including initiating devices, notification appliances, and the fire alarm control panel. Therefore, it's essential to choose the correct type and gauge of wiring to ensure optimal performance. There are several factors to consider when selecting fire alarm system wiring, including firstly, the type of system. Conventional systems typically use simpler wiring configurations than addressable systems. Secondly, the distance between components. Longer distances require larger gauge wiring to minimize voltage drop. Thirdly, the environmental conditions. Wiring exposed to harsh environments may require special insulation or protection. Fourthly, the applicable codes and standards. The National Electrical Code and other applicable codes and standards specify the minimum requirements for fire alarm system wiring. Common types of wiring used in fire alarm systems include copper conductors, shielded cables, and fiber optic cables. Copper conductors are the most common type of wiring used in fire alarm systems. They are relatively inexpensive, easy to install, and provide good electrical conductivity. Shielded cables are used in areas where there is a risk of electrical interference. The shielding helps to protect the signal from noise and interference. Fiber optic cables are used for long-distance communication. They offer high bandwidth and are immune to electrical interference. The gauge of the wiring is also important. The gauge refers to the thickness of the conductor. Larger gauge wiring can carry more current than smaller gauge wiring. The appropriate gauge of wiring depends on the distance between components and the amount of current required. It is important to consult the National Electrical Code and other applicable codes and standards to determine the correct gauge of wiring for a specific application. The installation of fire alarm system wiring should be performed by qualified and experienced technicians. The wiring should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. The wiring should be properly supported and protected from physical damage. The connections should be made securely and properly terminated. Regular inspection and testing of fire alarm system wiring are essential to ensure that it is functioning properly. The wiring should be inspected for damage, corrosion, and loose connections. The wiring should be tested for continuity and insulation resistance. Any deficiencies should be corrected promptly. Proper selection, installation, and maintenance of fire alarm system wiring are crucial for the reliable operation of the system. By following best practices, it's possible to ensure that the wiring will provide years of trouble-free service.